Welcome everybody. This is day 2 of our 6-part Designing Smart Building Systems workshop. My name is Anup Mohan. I work for District Controls. Today I have with me Russell Horowitz from Somfy Blinds. Russell, say hi.
Hello. Hi everyone. How are you?
Hey guys. So through this series, we are building up from designing an intelligent building automation system all the way to integrating lighting, blinds, IoT platforms, and all things that encompass a smart building, what a smart building should have. The entire series gives 3 PDH credits to those who are seeking them. If you have checked the box at registration, you will receive the certificates automatically, and PI will be notified of your attendance. If you have any questions, just drop them into the chat box, and we'll try to get to them at the end. This is a 30-minute session, so in case we run out of time, we will still get back to you by email or other means. So with that being said, let's get started. So yesterday, I just want to give a quick recap, like a Netflix show, I guess. We got a sense of how the OT world is transforming due to advancements in the IT world. We looked at what features an edge device should have. When I say an edge device, it is the first layer of intelligence above whatever machine that is producing data. So in this case, we're looking at controllers as the edge device. So what features an edge device should have in a smart building as opposed to a legacy edge device, and how systems are built up and brought together in both wired and wireless formats. We also looked at features of programming tools and IoT platforms. I ran through the last 2 topics rather quickly, so I will revisit them briefly today. And while yesterday was all about the facilities manager and the owner, today is more about the occupant and the occupant experience. We examine how to set up a workspace using smart sensors and end devices. We also look at APIs, what are they and what the role they play in smart buildings. And Russell will come in to talk about blinds and how they are integrated into a building system, how you add intelligence to manage the blind system as part of everything else. And finally, we'll leave you with some resources to help you design your next smart building. So yesterday, we looked at the perspectives of a facilities manager and a building owner. A smart building has to satisfy the needs of these 2 people as well as the occupant. A lot of the times, we focus just on the occupant experience and forget how difficult it is to run a building and also to own a building. The owner needs to make money out of it and take care of her assets. The facilities manager is doing a very difficult job of managing a building and all its systems. So we want to make the life of that person or that team as easy as possible. So the smart building has to serve all 3 people equally. And today, with the way the market dynamics are going, we're looking at occupants seeking better safety, health, and flexibility in their buildings, in their office spaces, the same way they're used to in their homes. These are the topics that I kind of glanced through yesterday, which I couldn't get enough time to push in. I just wanted to add that programming tools and having them freely available. When I say programming tools, these are the tools that keep this are used to program a smart building and controllers in them. It is important, it is vital to have these tools freely available to the building team so that they can make the adjustments they need on the fly. Probably you and I both know that when a building is built and it's designed, even 3 to 4 years down the line, it's likely to be different than what it was originally designed and built for. So you're going to see a lot of changes over periods of time, and you want the building to be able to adapt with that, with new requirements, with new sensors, maybe new machines. So if the building is beholden to the original installer of a smart system and has to call them every time in order to make any kind of changes or adjustments, it is cost prohibitive and it is very difficult for them to keep the building up to date. So it is very important that when you recommend a building install a smart system, that you make the programming tools freely available to the building and their team so that they can make adjustments on the fly. We had a case pretty recently where a building in Manhattan was trying to participate in Con Edison's demand response program. And Con Edison has a requirement that during certain times of the day, when they give you a notification, you have to turn down your equipment in order to avail the money that Con Edison gives you for participating in the program. Now, over time, this building had added exhaust fans, a number of equipment that they could not integrate into the BMS because it was cost prohibitive to call the branch office every time to add these things to the BMS. So when it came down to those little time windows that Con Edison wanted the building to ramp down its operations, the building manager had to go up different floors and manually operate things and hope that he or she did it in the certain time that Con Edison wanted him to do it. So this was getting more and more difficult, and that's where if the tool was available to the building manager, their team could have easily programmed the new additions and programmed it in a way that it takes advantage of Con Edison's demand response program automatically, as opposed to running up and down the floors trying to turn off and on equipment. So the other thing is a lot of our work, even our work is done through the mobile phone. It's important to have these tools available, whether it's managing your IP network, or whether it's doing air balancing, or whether it's doing changing control sequences, to be available on your phone so that it's easy for the FM team to go out and change things. I kind of missed through this section of the presentation as well. It's important for any BAS platform to have a good data aggregator where it can take in sensor data from different sources. It needs to be able to correlate and correlate different data sets, and then have timestamps associated with it. And then it's important to have context, or adding context to the data by connecting the dots with locations, nomenclatures, and algorithms, and ultimately make all of this actionable by issuing alerts or recommendation. It's important for a building manager to see graphically what is happening in the building. So all these data sets and data points have to be mapped onto a good, easy to navigate graphical user interface, whether it's to change set points, whether it's to do scheduling, picking out maps of the floor spaces and relating data to different parts of that building, and ultimately a good and clear alerting system that they can easily see, understand, and acknowledge. With that said, we went straight into IoT platforms, which is an elevated view of a building or infrastructure, where the BAS data is only one component of an IoT platform. At this level, the building owner wants to see utility data, sub-metering data. They want to see different asset tracking aspects. For example, the building might have generators, wheelchairs, or forklifts. They want to be able to track those assets and see the characteristics of those assets along with the building data, along with the sub-metering data, and other data sets as well. So that's the part I couldn't cover yesterday. I'm just quickly glancing through them. And coming back to the occupant experience. So today we focus on the occupant experience. Today's offices look more like this, as opposed to a 9-to-5 setup, which is more rigid. You're going to have much more open spaces that are not that easy to control. Every occupant is demanding more individualized control, customization. This presents different challenges to the FM team and to the owner to facilitate the kind of flexibility that the modern workforce is looking for. So today you want to see the comforts of your home, like your, to change the mobile, to change the temperature in your phone, to have touchless everything. I recently helped a project in Manhattan where they asked us to integrate a touchless elevator app into the larger building automation app. So these are the kind of demands that we are getting from the market right now. So let's look at how you set this up in a space. Now, the most important aspect when you're trying to design any smart space is to select the right sensors. They are your eyes, ears, smell, taste, and touch in the space. And that's the input that your controllers are going to work with and going to use to control the rest of the space. So this is a section of our office in 5 Penn Plaza in downtown New York. And in this office, we wanted to have features like definitely a hands-free environment, environment control. We wanted to have room booking through Outlook and wayfinding to get your way around 3 floors of office space. So for this particular purpose, we picked out these BLE multi-sensors. They detect position, motion, temperature, and light intensity, and they communicate back to the controllers in the space, which have the embedded programming logic that manages the functions of the rest of the room. Now, as you enter this space, your phone picks up your position in a network of these BLE sensors. The sensors also are monitoring temperature and luminescence, so it understands that, okay, another person is in the space, the temperature is starting to go up, and it needs to make the right adjustments to the AC system. So once you're in the space, the app can, using the Bluetooth sensors and its motion detecting, it can guide you to the space that you're trying to go to. Say it's the meeting room on the left side. Once you reach your meeting room, you can connect via Bluetooth to the wall sensor and use that connection to change set points in that space without actually touching that keypad. You can do it through your phone itself. And then you can also adjust the lights and the blinds in the space through that same Bluetooth connection. Is how this space has been set up. Now, this was a specific use. This is something that we wanted to have in our space, but depending on the use case that you have, the most important thing is to pick up the right sensors, connect them to the controllers, make sure that they're compatible, and then ultimately program the controllers to adjust or control the rest of the comfort aspects of the space. Another reason we picked Bluetooth for this use case is because of security. The way the Bluetooth setup works here is that you can only change or control the space while you're in there. So when you leave the space, you lose control, you get out of the system, meaning that when you're home, you're not able to change set points in the office and make it inconvenient for others who are sitting there as well. So that's the reason we've designed it like this. Now, say that was done 5 years ago. When we set up the office, we have the BLE sensor and we have these touchpads. That was all we needed at the time. But times have changed now, and now you're looking at people asking for these kind of well stats, or these are air quality sensors. They're also asking for occupancy sensors and people counters. So when that happens, these are sensors or smart sensors that have come out much later than we first installed the system. Are you going to rip out the old system and put a new one when it's only 5 years old? Or are you going to integrate them into the same system? So for that system has to be capable of accepting the data that's coming out of these new smart sensors that were invented years after the original system was put in. So it has to have a certain amount of future readiness, by which I mean there has to be a way to accept and integrate the new data sets in the new communication protocols that are coming out. So the last thing you want is to have 5 panes of glass or 5 different apps trying to manage your own space. You want to have just one pane of glass, regardless of how many sensors you're adding to the space over time, to manage that particular space. So the way that's done, and this is now becoming a prerequisite for a smart building or a smart controller, is through APIs. Now, those smart sensors that you just saw, they are not BACnet sensors. They're not lawn sensors. You cannot connect them via a two-pair cable and a 0 to 10 volt or an on and off signal. Those are totally different data sets. They send data to a cloud, and you probably have to do a cloud integration or some kind of app integration as well. So that's where an API comes in. So basically what an API is that it's an application programming interface. It's basically a set of code that gives a software programmer a window into the controller and allows her to read and write the BACnet data in it, and giving it the ability to integrate or create new third-party applications. It is now essential to have controllers embedded within API so that it can communicate to the software world or IT world at large. So pretty much it becomes a bridge between your controller and a third-party application. So you have to watch out for controllers that are pre-embedded with API so that you can connect it to these new apps or new sensors that are coming out each and every day. In our case, our controllers are embedded with REST APIs. The REST API is able to transmit device information, network settings, all manner of files, system settings, user management, and ultimately it's able to convert BACnet objects into understandable language for software programmers. Another important aspect to have is a software development kit. Now, what that means is that you want to be, again, open to the IT world at large. You want to give the right tools for third-party app developers to be able to build different applications. For us, we only thought about lighting, blinds, temperature, wayfinding, and room booking. But there are now so many more apps that are coming into the prop tech world that we never envisioned. But they still need to work and they still need to communicate with the BAS system. So it is crucial to have a software development kit available for the IT world at large to be able to use the data that's coming out of the controllers and the BAS to make new applications that we didn't think about when we originally put it in. At this point, I just want to get Russ on board and then give you a taste into how he integrates his blind systems into a smart building. Russ?
Thanks, Anoop. So hi guys, I'm Russ Horowitz. I'm the National Specification Manager for Somfy Systems North America. Somfy Systems is the world leader manufacturer for motors and controls for window treatments. And we manufacture motors and controls for interior applications such as roller shades and drapery tracks, as well as for exterior applications such as awnings and rolling shutters. And while our core business revolves around motors and manufacturing motors, we really like to focus on the control side of things. And when it comes to control, Somfy offers a large array of standalone proprietary control systems. And that's kind of been an important business for us for many years, but we're starting to see a change in the market. And that's leading us towards more and more integration into third-party systems. And we have many different bridge devices that allow us to integrate into third-party platforms, but we're also seeing many of these third-party control systems actually developing their own integration components as well. And you can see here in the architecture picture presented in front of you that there are sun and blind controllers manufactured by Distech that actually sits directly on their network. So with that said, let's talk about some of the benefits of integrating shade control. Next slide, please.
Yeah.
One back.
Oh, I'm sorry.
That's okay. All right, well, I guess we'll talk about the blind controllers first, and then we'll get into the benefits. So we have a few different options for integrating into a control platform. This is the most basic form. So this is a standard motor. So it's a basic relay motor, up and down and stop. And we can connect that directly into a Distech controller, which sits directly on their network. So it's very seamless, low integration, low cost, and it can bring a lot of value out to the network. It's very simple to add this into a system to add automated shades on top. Next slide. Now, if we want to get a little more in detail and we want to tie in directly to BMS, we do offer a BMS interface, which allows us to tie into a BMS control platform via 485 or IP. This system offers 1,500 data points, will provide feedback, and really allows the BMS to determine shade position and send commands down the entire network for an entire building to control that system. So if we want to lower the entire east facade, we can very easily do that through the BMS, and we'll still have the capability to add local controls for offices or conference rooms, so they can control those shades locally, but we do have the ability to move into the entire building or an entire facade from one button press. And last, we have our 0 to 10 volt integration. This allows us to tie into a basic 0 to 10 volt controller, and it can control multiple subgroups of shades. So these groups will be more locally controlled. So maybe we're going to have 1 0 to 10 volt in a conference room, and that integration will allow us to control that group of shades exclusively. We may want to extend it out to an entire facade, where through the 0 to 10 volt, we are controlling that entire facade, maybe through the sensors in the building. But because there are offices and conference rooms, we also have implemented local control to allow for smaller subgroups to be controlled as well. Next slide.
Russ, one of the questions we have is, say you want to program for the circadian rhythm, you want to have the blinds go up and down in rhythm with the light outside, and
Sure.
also have the lights inside to turn on or turn off accordingly. How do you go about doing that?
So that's through shared sensors, which is the next slide, the benefits.
Oh, I think this is the last one we have with the blind.
So there was a slide that talked about the benefits, and I can kind of run through it. One of the main benefits is shared sensors. So the ability to utilize sensors that are working for lights and shades, there would need to be some development done to ensure that whatever the requirement is for those sensors, that it's programmed throughout the system. But we can program sensors to manage light levels and make sure that we have an adequate amount of natural light coming into the space, as well as electric light as well. So that's one way that we can work with circadian rhythm and ensure that we have the proper light levels. I know Well V2 has a large focus and an increased focus on natural light in spaces. And we are working to ensure that there's an adequate amount of natural light coming into the building first. And then that natural light, if we need to offset it or add more, we can use the electric light to really offset the difference. So we want to make sure that we're using natural light as our first response, instead of just walking over to the light switch and putting it at 100%, which is what we're pretty used to doing in current buildings. So that's one of the benefits. Another key benefit that we have is one local controller. So the ability to have one keypad on a wall that will allow us to control shades, lights, HVAC. It makes it easier for the user, not having 3 different controllers that they have to learn how to utilize, as well as reducing infrastructure costs, as well as reducing hardware costs. So those are the 2 benefits that we have. Anoop, thank you. I'll pass it back over to you.
Thank you, Russ. One other thing I wanted to ask as well is, and this is something we've discussed a number of times with Local Law 97. A lot of people are focused on making sure the building complies with the energy codes and whatnot. And one of the things a good blind system, automated blind system, can provide is some level of energy savings. How do you see that playing out? Especially people have preferences sitting inside the space. They want to control their blinds up and down, but at the same time, you want to have certain energy savings, and you've programmed it in a way that you take advantage of outside light, etc. Do you have some experiences on that?
Sure, and a big part of that comes down to working with our partners, who are actually the shade manufacturers. So when it comes to energy savings, a lot of that has to do with the fabric choices. Obviously, there are high performance fabrics that are out in the market that could have many different energy savings properties that are built in. It could be reflective fabric that helps reflect solar heat gain back out the building. It could be one that has an aesthetics property that matches what the architect's looking to do, but also has some high performance characteristics built into it. So the automated shade, the automated motor and control component is one part of it, but we also need to take into account that fabric piece. And that's a very important part that plays into the energy efficiencies of an automated shade solution. So it's kind of the whole system put together. The automated shade is one part, ensuring that, the shade is down when we have direct sunlight on that facade, but making sure we have the correct fabric associated with that as well is just as important.
Gotcha. Thank you, Russ.
No problem.
And like Russ said, getting all these things into one pane of glass or one app is the focus of how we go about designing these smart systems, because the last thing you want is an app for blinds, an app for light, an app for HVAC, etc. So you want it all to come into one place, one unified touchpad, so that the user interface is seamless. With that said, the last thing I have, and I'm going to give you a few resources before I let you go, is just to understand the comparison of a typical Division 23 project and what we would consider a Smart Building Division 25 project. Now, based on our experience when we started off doing some of these projects 4 or 5 years ago, we worked with the owner, we worked with the engineer, but due to lack of experience, due to lack of knowledge of how to pull it together, we had the technology, but what ended up happening was in our earlier projects, when they were designed, and just the way engineers are typically set up, the HVAC aspects would go to the Division 23 office, the mechanical office, and then the Division 26, the lighting and the electrical aspects would go to the electrical office inside an engineer. And because they were not designed together, it was hard on the field to come and ultimately unify this and make this all work very seamlessly. So what we learned is that in order to make a Division 25 project work, it has to have perfect communication during the design stage. So in the engineer's office, you want to have the electrical engineers and the mechanical engineers work really closely together, along with the owners, along with the manufacturers, to come together with a unified spec, a Division 25 spec that pulls everything together seamlessly, so that once we hit the ground, we go to the installation phase, everybody knows which zones are what goes into each component, and the programming happens seamlessly as well. So having said all of that, I encourage you to go to districtcontrols.com/NYC. Here we have some tools to build out specs. The tool has the ability to take in the inputs that you need for that particular project and pretty much churn out a spec book, a short and a long version that reflects the parameters of the project that you're trying to design, and not just a big 300-page spec book that just covers everything and things that you don't need. So we have some tools there for building your own spec. We also have the previous talks that we have done, whether it's controls fundamentals, smart building systems, and many other resources that you will find useful to build out your next project. So with that, I'll leave you with all that, and then just from myself and Russ, just want to wish everybody to stay safe. Join us next week on Wednesday at 12 p.m. for integrated lighting controls and how you bring that into a smart building. So until then, see you all. Stay safe.
Thanks, guys.